Welcome back, ladies and gentlemen. We're back with our motor frame sketch, and today we're going to go ahead and continue. We're going to add the dimensions to our sketch so that we can draw this motor frame. This time we need our dial caliper as well as our motor frame and our sketch. Let's figure out first, before we start doing any measuring, let's figure out what we want to measure. Well, let's see. We have overall heights and widths. So we have an overall width for this object. We have the depth of an extrusion here. We have the thickness of our parts. So this is the depth of the part, how far it is from front to back. We have an overall height. We have some radii. There's an arc there. We got a hole. There's a bearing diameter. I don't know whether we'll be able to reach in there and measure that. Let's see what we can do. We have, let's see, there's the hole again. There's the outer bearing diameter for the housing. Well, there's a circle here, an arc that needs to be dimensioned. Get the width, height, bearing diameter. That might be all. So let's go ahead and get those measurements. We're going to use our dial calipers, and we're going to measure, let's go ahead and measure the overall width of the object. That's pretty easy. So when we read our caliper, this is a 4-digit display. So we got 2 digits on the blade, 2 digits on the dial. 0 whole inches, almost 6/10, but you can see we're to the left of the 0, so we're at 5/10, 0.589. 0.589. Now that probably looks, look at that here, there's also say, shouldn't that be 689? Well, 589 is almost 600. If I go 689, well, that would be almost 700. So this is 589 1/10 of an inch. Measure the height, the overall. What do we got here? Again, almost 8, so 0.784. So 184 thousandths. We've got a hole in the center. Not going to really get in there. That's really too small to measure with that. I can estimate it this way. That's not very precise, though. There's a better way to do that. You know, I bet you I've got an idea. I've got a set of drill bits here. And these drill bits come in a variety of sizes, and they're all numbered. So I could try to figure out what size hole is in there by trying different drill bits, and that one fits. That one's too big, so the hole diameter is going to be the size of the drill bit that best fits in that hole, because that's how you would make that hole anyway. Let's go ahead and measure that now. 0.0, we're not quite to the 1, 76. 0.076. And that's a diameter. I forgot to mention that. Anytime you do a measurement on a circle, make sure that you state whether it's a diameter or a radius measurement. So this is a diameter of 0.076. Remember, with arcs and circles, they're either measured as a diameter or as a radius. And that's kind of confusing if you don't tell people which one you're going to get. Okay? I'm not going to be able to get that inside here. I could measure this, but that's actually the outside of that. This is the bearing that's on the inside. So they're not going to be the same size. I don't know. We'll try something else. Let's do some other math, see what we can figure out. So we can get that measurement over here. 0 whole inches, 2/10 of an inch, and we'll call it 32 thousandths. So that's a diameter measurement again. It's all the way across. And then 0.232. Remember, for round things, we have to always measure show the diameter, whether we're measuring diameter or radius. Now we're looking for a radius here. But if we imagine this to be a full circle, then all of a sudden, figuring out that radius gets a lot easier. Because I'd have a hard time measuring that any other way. But we did get that circle measure. They get that diameter. We got that diameter over here, 784 thousandths. So that radius we're going to get the radius we're getting is going to be half of the measurement we took earlier. So half of 784. Let's see, 350 is half of 7. So 350, so 0.350. Half of 84 is 42. So that means that our total is 0.392. So 0.392. And then you can just use your dial calipers to finish out the rest on your own. This is how we get our dimensions. Once we have these dimensions, you can go ahead and start modeling this up in CAD. Alright, great job. As always, keep being awesome.